Alright, welcome back for more of Odinmade Hero. Hopefully I've started the stream off without any technical mishaps here. It is happening less. I think it's happened barely at all this week. I've left myself on mute a few times maybe, but the issues are becoming fewer and further between, which feels good. At least that's how it feels. I haven't actually counted because that would be way too autistic of me, which I want to be anyways, in the best of circumstances. But all that aside, we're back for another day. Learning how to make a game from Casey Muratori here and his Handmade Hero series one day at a time. Yesterday, we were working on implementing a little bit better movement code, adding some notion of acceleration to our little hero here so that he can glide around and the movement can just feel, quote unquote, better rather than just a sudden stop and start. He kind of picks up momentum and starts going. And so that's kind of cool. He glides around, but then he gets stuck on these walls. And so that's what we were looking to work on next. That Casey was going to go ahead and show us how to work through, figuring out how to kind of have him bounce off of the walls here. And so that was at the end of day 43, and we're on day 44 now. But like day 43, day 44 had a lot of whiteboarding up front. And do I have the right thing popped out here? Yeah, I think this is right. So there's a lot more whiteboarding again in day 44 and then again in day 45. So I'm going to be a little bit ambitious today and try and knock out 2 days in one stream. I don't know if I'm actually going to be able to do it, but I think I can get fairly close because there's only 20 minutes left of coding in day 44. And then day 45 works on more movement code. So it's, pretty closely related stuff. But we're going to start off with reflecting the vector here as our hero just kind of runs into that wall. I'm getting turned around here. I have so many windows open. So rather than getting stuck on these walls, Casey kind of goes over the math in day 44 here of how we're going to go about doing this. And it basically revolves around this equation here, where we use the inner product with a unit vector and the velocity vector and, do some vector math here to get it so that we're bouncing off of that wall instead of catching it. And I probably articulated that wrong, but that's okay. I'm not too focused on getting the articulation of it right as much as I am focused on building an intuition for how to do any of this at all. Because when I first worked through this stuff in the Zig programming language, before I swapped over to using Odin in the past couple months, I was just trying to keep up and also just get to the end result. Whereas now I'm trying to take my time and really concentrate on internalizing the concepts that he's trying to drive home with these videos here. So before we jump into that, I did want to say thank you to Gunther, who gave me a Twitch Prime sub yesterday, and everybody else who has followed the channel within the last week, whether it's over on Twitch or on YouTube. I've been picking up more, whatever each platform calls them, followers, subscribers, whatever, on each platform. And I appreciate all of you who are coming along for the ride. I'm sorry I didn't have that notification. I didn't notice until after I ended the stream, Gunther. So hopefully you'll accept my apology here the day after. But for anybody else who's following or subbing and things like that, I still haven't turned on notifications, and it's because I don't know how I want to handle notifications. I have a very limited amount of time to work with here on stream, and I want to make sure I'm using it as effectively as I can. But maybe it'll be a thing where I can turn on notifications at the end of the stream and then express my gratitude then for those of you who are either subbing or following and or donating. I don't even know if I have donations set up anywhere at this point, but I imagine it, if and when I feel like it, I will. It's just about making the time to set up those notifications, because right now I don't like some of the notifications. They're either way too long or way too loud or just altogether the wrong thing. But I promise I'll get that figured out. I'm just trying to lean into the purpose of the stream more than the actual content creation aspect of the stream, you know, because I'm not as focused on the content creation. I mean, this is content in a sense, but really what I'm here to do is learn the thing and also hopefully, you know, share information, share insight, and just discuss not just, you know, games programming as much as that's the main topic, but also ways in which games are relevant to like the human experience, almost as kind of almost asinine as that is to say. I do think that games have a very interesting quality and that they work with your input as the player. Whereas if you're reading a novel or you're watching a movie or something, you know, some other entertainment medium, if you're playing a board game, you know, that's different. There's actually, you know, you're probably playing that board game with other people, but a game is kind of one thing where you can play it solitary and have it works with you to create an experience. And there's just something about that. It's also a relatively new medium. I mean, at least compared to books and movies, right? I think movies have probably been around, like, when were the first films made? Like in the early 20th century. So movies have been around perhaps 50 years longer than games-ish. You know, I'm not sure when the first video game was ever made. I'm sure some game historian would know. I'm sure Google would know, or at least Google AI might know if Google AI wasn't wrong half the time. So we can't trust that. But anyways, all those asides aside, I appreciate everybody who's tuning in, and I'm excited to see how the channel grows and where it goes, because I don't fully know myself yet where this winds up. But I know what we're doing today, and that's enough for me. Let's go ahead and jump in. In fact, I don't even think I need to switch over to Casey. We're just going to jump right into some code here.
Okay, hopefully that'll stay up long enough for me to answer the questions. Okay, so let's go ahead and do that. Let's go ahead and just implement this. So I now want to do a thing where I compute that bounce.
Just realized he's not playing at my... Oh gosh, why did this happen? That's right, I failed. There's my mishap. I failed to reload the video before playing him. For whatever reason, YouTube just gives up. It can't like seamlessly continue a stream of the video to the player. It has to always reload the page.
Back up.
If it's been
too long. So I will actually be able to see questions at the end, so sorry about that. Again, not the best situation for Linux.
There we go.
Let's see. Is it so hard, people? Is it so hard? Questions. Yes. In order to do that, I know that I need a dot product. So we'll open up our math routines and add one. So in line, again, it returns a scalar value, inner product.
So he's going to write his inner product procedure from scratch. I'm going to go up here, and we're going to add a new math import to the linalg package, which is this handy-dandy linear algebra package. And of course, this is showing the wrong thing, because why would you show the right thing, OBS? I looked at this before the stream started too, and it was showing the documentation. Okay, there we go. If I go over here, and I'm in the POW procedure over here. Can I get out of here? Just go back to packages. And linalg, the linalg package just kind of gives you pretty much everything you would care to have as far as linear algebra goes, right? So lots of neat stuff in there that I'm sure I'll make quite a bit of use of. So unless I'm forced to implement something myself from scratch, either because the use case demands it or I can't figure out the right Odin call to make, I'm just going to stick to using this. So if I go back down here and I access the linalg package, or I guess technically it's a module to a package. How does that work? No, the OLS calls math a module to. I try to get those things right, but I just don't know, because I haven't spent enough time in the Odin world to appreciate like what's the difference between a module and a package. Are they the same thing? And then we can say inner product, and then I think if we go to the definition of this, well, I guess I could just call it dot. Call it as dot. if we were to do it like Casey is doing it, we would stick to inner product. But I always like a nice abridged version of a procedure name. So maybe we'll just do that. But then you can see, and this is something that I haven't messed with too much, but I think like a procedure group is what I'd want to do for like those tile map procs that he is overloading. This is like a way of overloading, but it's not actually overloading. So I could have named, for instance, my Odin tile map where it was like get tile value, and then there was 2 different versions of this procedure. I could make it a procedure group, which is what Odin calls it, and then it would map to like the names that are more verbose, which correspond to the actual thing that I'm trying to do. So I might experiment with refactoring that code a bit so I can have something like that, because it would be nice to kind of get the function overloading but not actually overloading any functions. It's just that this maps according to the parameters that you're passing in, which correspond to whichever of these procedures are here underneath the hood in the procedure group. Again, probably explaining or articulating some of that incorrectly, but I think I understand the implication there. And so this is just going to use some more parametric polymorphism, and then we can come in here and do the thing. Welcome, Devil. The lin-alg library helps with linear algebra. Yeah, isn't that crazy? Isn't it awesome when a name just tells you exactly what you need to know? So I'll just use the dot procedure off of the lin-alg package, and I think we'll be good with that.
It takes 2 things, and I might just call this inner because I use it so often, it's pretty obvious what it actually is.
There you go. So he started off calling it the inner product, and then he just changes it to be inner. But I don't think there is such a thing, right? It's either inner product or dot. We'll just go with dot.
And so the result here, again, very straightforward. It's just ax times bx plus ay times by. Okay, there we go. Turn that there. And so that's our dot product, inner product, scalar product, whatever you want to call it. And that is what we're going to be computing to do our reflection code. And so if we want to reflect here, basically this is in the case of the tile point not being empty. I guess what we could do is say, all right, then if the tile point is not going to be empty, then we basically have to figure out what direction the wall was actually in, which we haven't actually done yet, but let's pretend that we do have that. So we basically have our r, again, this is going to be some value here, which again is that r from this equation. And what we need to do is take our velocity, which again we have, if the game say d player p, and what we need to do is reflect it about there. So what we need to do is say, okay, we've got the d player p, and the new d player p for this frame, or I guess, have we actually retired the point yet for this frame? We did the test, so I guess it'll just be for next frame if this count. So we take that d player p. We're going to have to work on this player motion code a bunch, to say the least. But anyway, we're going to take that old d player p, we're going to subtract 2 times the inner product of whatever it actually is, and our wall vector, right? And then we're going to multiply that by the wall vector itself, right? So there we go. That's the actual equation.
So just like what he had on the whiteboard, minus 2 times the lin-alg dot dot. I'm going to break this up on a new line. And it'll be, what was it? R, whatever R is going to be. And then, is it the velocity? Yeah. Oh, and then times r. And so this gives us that vector, but we're subtracting 2 of them to bounce away in the other direction. Set the player's velocity to go off in the other direction. But we're not done yet.
And oops, those were lowercase. They should not have been. I wonder if I should make those lowercase. That's a good question. It lines up better with the shader code if you make them lowercase, because shaders have .x, .y, that sort of thing, if that makes sense. All right, so what we need to now know is what actually is that. So let's hard code it.
Hey, Boston, Mass. I skimmed through some of your YouTube VODs and couldn't find any on-screen game footage. Have you shown your version on stream? You might need to elaborate on what you mean by screen game footage for me to give you a good answer. Welcome, Anna James Arts. Thanks for dropping in.
First, to make sure that we actually have our stuff working at all. So if we actually wanted to bounce off that bottom wall, that bottom wall is going to be obviously just the y-axis. So this should do the initial thing that we just sort of said was what we would do.
On-screen game footage. On stream. I'm just trying to interpret what you meant. If you explain what you're asking for a bit more, then I can hopefully answer.
If we didn't actually have the dot product or any of that stuff. So let's see. There we go. Of course. That's pretty funny.
I must have missed where he set R to something. Yeah, he just set it to be, what was that? Y going up, right? Like that. Like that. Feels like I'm bouncing too much, but maybe it's because I had the... Yeah, well... Yeah, this seems really slow. I wonder if I miss something here. But now we're not catching on the wall, which is nice. We can just bounce off of it over and over. Kind of like we're playing air hockey or something. But... Yeah, something seems incorrect with the and I can't see what he has his velocity set to currently, or what the I guess more what the acceleration would be right up here. Something about how I have this configured seems wrong, but I shouldn't worry too much about it. Actually, it looks like he left this as 0.5. Is that right? Yeah, no, that's just below there. Yeah. Well, another thing I was curious about is, like, if we only subtract 1 length of that vector, like, what happens then? Yeah, we just kind of stop on the wall. And we do get stuck. But it definitely feels a little bit different. Yeah, we can actually, so if we kind of stop holding down as we hit the wall, we can still manage to glide. But the problem, like he points out, is that it's still not finished because we want to be able to glide against the wall while we're pressing down. But this way, at least, you know, I'm not getting stuck on the wall on the bottom. And you can see that this, actually, that works the same way. So I think it's just because it's like evening out, maybe. Hi there.
Hi. Hot.
It looks hot. I can see it steaming. Thank you. Love you.
Love you.
My gorgeous wife just brought me some chai tea. Need a little bit of caffeine to make it through that afternoon slump sometimes. Boss and Mass said, "Oh, I'm dumb. When that was showing, I thought that was somehow Casey's version from the YouTube video. Don't mind me." Oh, I see. I think I see what you're saying. Yeah, no, that is actually my game, right, that I'm writing here. But it sounds like you cleared up that confusion for yourself. Hopefully, yeah. Hopefully we both understand what's going on now. So anyway, yeah, so let's add that 2 back in. It just feels like his is, well, maybe it's because, you know what, this is not the first time I've done this before, but I'm pretty sure it's just because he's going in 1.5 times speed. And I'm like, why does it look like his is faster? It's because it literally is. Quit forgetting, right? Like if I go back here.
Of course, any of that stuff. So let's see. There we go. Of course.
Like, how does it... That's... He's not bouncing right off of it. He's kind of... coming down here and then going... Yeah, that's way too much. I don't know, maybe... I don't know, I shouldn't get too hung up on this because all of this code is going to change anyway. I'll just keep moving forward. Something just doesn't feel right, and I don't want it to be because some very important constant that is going to stay in the code, you know, for whatever reason, is somehow not lining up. But I'm sure it'll work out.
That's pretty funny. Yeah, so there we go. No problems there. It seems to work pretty good. Of course, I'm accelerating against it, so I kind of... There we go. Yeah, so that's pretty straightforward. Nothing much to see there. Now, of course, the problem would be if we actually do that, we would have the wrong... we would have the entirely wrong behavior because we're not actually computing the wall correctly. So what we do need to do is figure out some way to actually figure out what the direction of the wall is that we ran into. And I don't think we really know very much about how to do that at the moment. I guess we would have to sort of say, well, when we check these points, right, the new player P, the player left, and the player right, we need to figure out which ones of them are not actually allowed, because we don't really have much in the way of collision code at the moment. We'd have to figure out which ones of those were interpenetrating, and for whichever ones were interpenetrating, we would then have to figure out which direction the step was between the current position and the new position. Like which direction we stepped in the tile map would tell us where the wall is. And this is one reason why, you know, like I said, later on, I don't think we're going to be doing any collision detection on tile maps because it's just kind of annoying, and I don't think we probably want to have like a more interesting boundary around things. So yeah. So I wouldn't basically put much weight into this particular stuff, but the bounce code is correct, and so let's keep going with that. Anyway, so let's say that what we do here is we take a look at these guys. I guess we could just say whichever one of these, yeah, this is kind of ugly, but let's just do it because we might as well, we're here. So we've got a bool 32 that's going to say, you know, I guess, well, you know what, I don't even need one of those. Well, I do, yeah, I do. Okay, so we'll just say collided. Again, this is really bad. This is not at all what I would advise doing, but I just want to, we're working on the wall code right now, so I don't really want to spend any time thinking about it. I just want to do something where we can get our wall out and go. And since we know we're not going to be doing collision detection this way eventually, it's not particularly interesting to me to think about it much more. So basically, if a tile map is not empty there, I'm going to say collided equals true, right? Like this. And then I'm just essentially going to do that same thing here. So
go ahead and get caught up with him. So taking this out and then checking each of these individually. This is really messed up. That was a nasty yank. And, yeah, whatever. Just do it. Don't think so hard about it. Try and get clever with your Vim commands. And then, well, actually, now this is all wrong. My indentation, I'll just notice, is busted randomly from getting too clever with the way that I'm moving code around. So it's going to be something like that, right? And instead of checking whether it is empty, we say if not. And if it's not empty, then we have to say we're colliding with one of those walls.
So player right, and player left. So I'm just going to take a look at those collideds, and if I did collide, then what I'm going to do here is say that there's a tile map position, call P or whatever, and that's going to equal in the case of collision whatever we actually found was the collision and trigger, right?
I'm just going to spell that all the way out. Because call P makes me think of column, like column position. Collided P, I think feels good. And actually that's a tile map position. But is tile map position, am I zoomed in right? Yeah, that feels right. Tile map position, yeah, okay. We're good with that. Right, because we're going to assign it to be the new player P. Yeah, that's exactly what he did. So that way, whichever direction we're colliding in, we're holding that position. And then I assume we're going to derive the unit vector that we're going to reflect with, or transpose with, right? Transpose the, what do you say? Velocity transpose reflection vector? I think I'm saying that right.
Whoever actually collided. And this will let me know.
Oh yeah, I got that wrong. Because right here, we're not colliding with the new player's position, we're colliding with the player's leftmost dimension. That makes sense.
What actually caused us to not move, right? And so this now becomes collided. If we did not collide, right, then we can go ahead and do yeah.
Yeah. Okay. Yeah. Because that's the opposite, right? We say if not empty, then we can go ahead and move into that new space. Otherwise, then we have to handle that collision.
Go ahead and do our stuff. And so that shouldn't change anything as it is, right? We should still be able to do whatever we were doing before. But now we can compare and figure out where our wall actually is, right? So if we want to see where the wall is now, we can essentially say, well, we know we collided, right? And so in some sense, we could reverse the sense of these so that we could get rid of that knot there so we can actually see more cleanly. If
that does feel better. So pull that out, he's saying, in favor of it being the true case. And we still need to make sure that this R is being set to the right thing.
We collided with something. We just need to figure out what our wall is. To figure out what our wall is, we then go, all right, we know col P is the thing that collided. So what we need to do is take whatever the player P is, right, whatever the player P currently is, which is this guy. And we just need to see what direction he was trying to go in the tile map, right? So if you remember, here, we have the tile map position. We have abs tile x, y, and z. So we just need to look and go, all right, if the abs tile x is less than the abs tile x here, then we know that this wall was a wall going in descending. The player was moving from like to the left, right? The player hit a wall to the left, and we could do the same stuff in all the directions. If it's greater than, and if it's that, so on. And since we can't really make anything collide diagonally at the moment, I guess we don't really need to worry about that case. But anyway, here we go. We can basically do, I think.
Okay, let me see if I can do this correctly without copying Casey straight up. So, yeah, X and Y. And so if this is less than, so he's comparing against the original player state to see if we're colliding either on the left, the right, the top, or the bottom. And actually, I should just go ahead and do that. And then these should be comparing with the Y. And so if we're colliding with the left wall, then, and I guess I should just zero this out at first. Yeah, that's what he does. Like so. And I think we can just infer the type. We don't have to specify that we're assigning to a V2 because we know that's what it is. So it's going to be something like this. Well, it's going to be on the X. So if it's left, we want to bounce to the right, go positive in the X direction. So 1, 0, right? And then over here, it would be the opposite. And then just do the same thing for the Y. This should be a greater than. And so for the Y, to think about this more carefully because Y, the direction that Y is in, I can't remember at which point we start treating it as up or down, but I think we can treat it as being up. Y is going in the up direction. So if we're colliding with a tile that's south of where we're at, then we want to bounce up, which means that I think this should be positive. And then it simply makes sense that this would be the opposite. Is that right? We'll see. We'll see what Casey does.
People were saying we could do this, right? Yes. So, given that we've got, what was the complaint? Oh yeah. So given that we've got that, we basically just need to define the wall for each of these motions. So in this case, I'm moving to the left, so that means the wall is like its normal pointing out to the right. In this case, I was moving to the right, so I have the wall pointing to the left. In this case, I am moving up, and so the wall is pointing down, right? Is that correct? Yes. Wait. No, it's less than. So it's moving down. So it'd be up, right, and then that. I believe that is all of them. Potentially entropy is used. Well, if it collided, we know that. Well, all right, fine. We'll just do this.
Okay. So we build and run. And now we can bounce off of any wall. Looks like I was right. Whoops, didn't switch this over. So that feels good. I know which direction X and Y go in. Now I could really make a an air hockey game. Like a silly mobile game, right? I've seen other people compiling, or rather shipping Odin code onto iOS, and I think it's possible on Android too. So we could totally do that, make a mobile air hockey game. I think if I only understand... I was still a little bit confused about what you were asking, Boston Mass, but basically what you were asking, right, is you were asking whether I was showing any game footage of like the version of Handmade Hero that I'm building. Yeah, so I never really explicitly said this, to be fair, but whenever it's showing up here in the top left, can you actually see my mouse? OBS is in my way, so I can't see my own mouse when I'm looking at the game on stream. Yeah. So over here, this is my version of the game. And then Casey's version of the game is just always, you know, inside of his own window here. So if I'm here, and like if we're on the Casey scene, then if you're seeing the game, that's his game. But if you can see my editor, then it's my game. Yeah, that is exactly what I was confused about. No, I mean, it's not you being dumb. I never explicitly even said it. I just kind of, you know, set up the stream this way and just kind of assumed that people would put it together. But I take it for granted that just because it's that's the thing about assumptions, right? I just kind of assume that people would be able to infer that this is my version of the game, right? And to be fair, I want to, over time, like distinguish my version of the game from his to further separate it apart. And then eventually we'll go off into territory where I'm hopefully making my own games on stream, right? And so to that effect, you know, I don't know that I'll actually do that with like the game code that we're working on to learn from Casey, because, you know, I certainly don't want to give the impression that I'm going to basically yank all his code and then ship a game with it, right? That's not my intent. So if I use different art here, like my intent was to either use some free sprites that I could find online and free assets that I could use to just, you know, throw my own stuff in there, and then inevitably I'm gonna have to change some code to get that to work right, you know. So I think if I get that far, I would set it apart that way. Then it would be that much more obvious. It'd be apparent, you know, when you're first looking. Oh, this is, you know, not Casey's Handmade Hero. This is James's Odinmade Hero. But it's just kind of a weird format in general, right? Like any day now, I'm waiting for Casey to email me and tell me to cease and desist because he thinks what I'm doing is weird and creepy. But I'm hoping that's not the reaction he would have. We can make a DVD bounce screen simulator. Yeah, there's all sorts of things we can do now. My head is swimming with ideas. I only found your YouTube yesterday when looking for Odin videos. You're dominating the recent videos there. Well, that's good. Well, maybe it's good. I don't know. I hope that people that are looking for Odin content would find this interesting. There's only one other person doing content on Odin that I'm aware of, other than the creator of the language, right? And that's Carl Zielinski. And he's like actually a pro game dev, whereas I'm just a cursed web developer who's trying to make time to learn games programming in his spare time. But I figure, you know, it doesn't hurt to do anything that promotes Odin in some way, because so far I'm really enjoying the language. It's the first language I've found in a long time where it just feels like a lot of fun to program again. So anyway, all that aside, hopefully you're enjoying things, you know, what I'm doing here too, as confusing as it can be, because, you know, it's not just we've got a bit of programming inception happening here because I'm programming on stream, and I'm also watching Casey as he programs on his stream from 10 years ago. It's a little weird, and I don't take that for granted. Definitely, I really want to give it a shot, so I was looking for content. Happy to find your stuff. Well, glad to hear it. Hope to see you around more. Okay, so let's jump back in here.
There you go. And we know that these cases can actually happen, but the compilers are being a bit persnickety there. So in theory, that should give us bouncing off of all the walls. Yeah, there we go. Right. And so now we're just a bouncy little fellow who's pretty happy about his lot in life, very determined to go around bouncing along things. And the faster we go, the harder we bounce, which is exactly what we wanted in terms of our behavior. Now, like I said, if we wanted to, we could make him bounce a little softer off things by basically adding a coefficient in there. It's called a coefficient of restitution. The coefficient of restitution would basically be some number less than 1 that we would multiply our vector by to reduce how far out it went. And so that's really all that is. Yay, bouncy fellow. Okay, all right. Sorry, I'll stop bouncing around in a second. That's kind of fun. Yeah. Now, in theory, we don't really handle the diagonal very well, and you can kind of see that. So you can see what kind of happens up in there, and that's because we only really handle bouncing off of one or the other at the time. And that's because, again, like I said, I don't think the tile maps are really that interesting way to do stuff, so I don't think we'll handle that eventually that way anyway. But what we could do, if we really wanted the tile map collision to be the way we did collision, what we could do is round those off a little bit, pretend they were rounded in there a little bit, and have a nicer collision there. But still, it's fine. I mean, it works. It's not pretty, right? Yeah. All right. So now I got another question for you. Because I've given you I give and I give, stream. I've given you everything now. It's time for you to give back, all right? You're the man now, dog. What I want to know is basically, I told you all this stuff. I told you about the dot product, right? Instead of keeping it a secret, it could have been only me that knew the dot product this whole time, and only I can do all these awesome things, and now you know it too. So tell me, with that power, how would you now do something else with the collision response? Let's say what I want to do is have him have the standard, the more familiar kind of Quake style movement, where if my guy runs into a wall, then basically he just runs along the wall like that. So instead of him bouncing out like this, he just kind of goes like that, right? Smoothly along it, right? How would I do that? Now there's a trick to this. One part of it I expect you to get, and the other part I don't expect you to get, because one of them is a programming thing, and we haven't talked about that yet. But you should be able to do the math part of this. Does anyone know? Anyone? Well, you're behind on the stream anyway, I know that, so I can't really expect you to answer right away. But the reason that I think this should be easy, and if you want to pause the stream and try to figure out yourself, I highly suggest it because it should be, is that...
Do I sit here and agonize over how I'm going to inevitably give the wrong answer as to what he's looking for? It's another transpose, right? Is it another dot product to get us going along the wall? Because we just want to go along the direction that the wall is going in, rather than bouncing off of it, I think. That's wall running if you ignore gravity. Now you're making me want to do like a free climbing game. And speaking of free climbing games, those types of games that make that really fun, there's one kind of game like that I never played that I always said I would back in the day. I always said someday I'll make a let's play of this, and I never did. But it was, I think it was first person, right? And it was like a PlayStation exclusive for like the PS3 or something. Mirror's Edge, was that it? But obviously, those kinds of games have always appealed to me, and I'm thinking of like those old Minecraft parkour maps as an example of that. But Minecraft parkour is pretty, naive isn't the right word. It's clunky. It's not really, it works because it's so clunky though. And there are many such cases like this with Minecraft, but I'm thinking of Assassin's Creed, right? At least the older ones, like Assassin's Creed 2. That game was fun purely because of how fun they made it to climb, Renaissance Italy or whatever it was. Climb all over the different buildings, and like you would look at like the tallest building and be like, someday I'll climb that. But there would be some story reason that blocked you from being able to climb the tallest buildings or something like that. Not saying that that's what I want to go and do is go make a parkour free climbing game, but I think that's the problem. I think I'm putting that off in many respects, but also there's clearly so much to learn before I can get to that point where I can actually take any idea seriously. There are so many game ideas that you could chase down, and just making like a simple prototype could take you a long time. Like you have to be very intentional about what it is you want to do. And I think just by experimenting on stream, once we get to that point where I can experiment with all these different ideas on stream, but just keep them very bare bones, that's when like certain ideas will reveal themselves to be more interesting than others, and they'll be worthy of, you know, fleshing out in more detail.
But I already told you essentially exactly what you need to do this. Instead of minusing 2, you could just subtract 1 version of this, and that would bring you right up to the wall, right? That would bring your velocity so that it was just along the wall. So what we could do is instead, instead of it being -2, right, I could just make it be -1. Now, like
Okay, so that's what I tried originally, actually, at the beginning of the stream, because I was curious to see if that was actually the answer there. Was it -2, like that? Kind of want to break this up. Am I on the right screen? No. Always got to check myself. Split that up over here. And basically saying that we do this instead. But I remember getting stuck. And I think he's about to explain why this answer isn't sufficient, maybe? Yeah. So if we keep driving into the wall, we still get hung up. But we can at least, you know, run along it. And as long as we're not trying to hold into the direction of the wall, we don't get stuck. But it kind of looked like it was doing that anyway. I guess I could prove that by just commenting this out. But this actually, yeah, no, because this would change nothing about it. Oh man, can I just do this? Shut up the, oh damn it. Yeah, no? Well, never mind. Forget I said any of this. I don't want to waste more time on this.
said, there's another trick to this though. So if I do that, there's another problem that we have to solve that it will expose that we really should have solved before.
Okay, so he is
we didn't really have
pointing
to
out that that's a problem.
Right? Now you'll notice when I come on here, right, you can kind of see, well, you know, it's not as pronounced as I thought it would be. It sort of happened a little bit there, but it's not as bad as I thought it would be. Yeah. All right, I take it back. Maybe we don't have to fix it. I felt like we would have to fix it, but I guess we didn't. But you can kind of see now what happens is exactly what I expect to happen, which is that if I'm going diagonally down, you get that grindy wall thing that you're supposed to get in video games where you go a little slower against the wall when you're pushing into it, and you go faster if you let up, right? Which is exactly what we want to feel. That's like a good game feel thing. And so that's, right, like totally trivial. But what I thought should have had to happen, and there you can see him kind of sticking a little. There we go. I was going to say, it should happen. I hope that you can sort of see how he was sticking there a little bit occasionally. There we go. Right there. See how he stuck?
Okay, that's super weird. So he's expecting to see the thing that I am seeing in spades, which is that if I try to grind against the wall at all, it just stops me completely. He was expecting to see it, I think, behave more like this, right? But he's seeing it behave more like sometimes he kind of gets stuck a little bit. So I don't understand why that is, because essentially our implementation should be the same, right? If I back this up, maybe there's some other small detail here that I'm missing. But he takes the original player's velocity, subtracts it by, well, he actually explicitly replaces this with 1 instead of just getting rid of the 2. Like I did. I did this and he did this, right? But I don't know why that would matter. That doesn't seem like it should matter at all. Right, so yeah. I think maybe this comes up again later. But the point is that we're supposed to be seeing this bug. This is what Casey is, well, not bug, but we're supposed to be seeing this behavior where we stop. And Casey kind of sees it, but not really. And so that's why he's a bit confused.
We didn't really have to in that case, right? Now you'll notice when I come on here, right, you can kind of see, well, you know, it's not as pronounced as I thought it would be. It sort of happened a little bit there, but it's not as bad as I thought it would be. Yeah. All right, I take it back. Maybe we don't have to fix it. I felt like we would have to fix it, but I guess we didn't. But you can kind of see now what happens is exactly what I expect to happen, which is that if I'm going diagonally down, you get that grindy wall thing that you're supposed to get in video games where you go a little slower against the wall when you're pushing into it, and you go faster if you let up, right? Which is exactly what we want to feel. That's like a good game feel thing. And so that's, right, like totally trivial. But what I thought should have had to happen, and there you can see him kind of sticking a little. There we go. I was going to say, it should happen. I hope that you can sort of see how he was sticking there a little bit occasionally. There we go. Right there. See how he stuck? So that's the problem that I was alluding to that we had to fix. So I was kind of glad that happened, because I was like, well, I told you, there he is. There he did again. Right? You see that sticking? Why is he sticking? What's going on? Right? What's going on with the sticking? I can hear you saying it. What's going on with the sticking? So the problem that we have, and this gets sort of to the heart of collision detection at some level, and we'll never totally escape this. I will show you the ways in which we solve these problems in practice, but we will always have to keep thinking about it. There's no magic bullet. Is that in the real world, collisions aren't some instantaneous thing. Everything is happening kind of continuously, and again, it's all atoms, and they're all working together and this sort of stuff. And collisions are this elastic thing where something deforms a little and dents a little and moves out, whatever, right? We're simulating collision like it's this fixed step thing, right? And so what we wrote our code to do way back when, this is not something we wrote today, but what we wrote our code to do way back when was go, okay, I'm here, here's my dude, right? So here's the hero, and he wants to go to here, right? But this is inside a wall. And so what we did is we disallowed the move. That's what we did. But what that means is now, when we have our code that's trying to do this stuff when we skate along the wall, we get into a problem where if the user is pushing down into the wall like that, right? We can correct that velocity, but we've already denied the move. So the hero essentially doesn't move on that frame, even though we've corrected his velocity, right? So what we really want to do is we want to see if he would have collided, and if he would have collided, we want to correct his velocity and then try to move him again. And you can see why this is a bit of a nasty cycle, because then your very next question should be, and legitimately should be, mind you, what happens if he collides then? So you're kind of in this nasty situation where you have to deal very specifically with the discreteness of everything and go, oh, I've kind of got this nasty problem where I've got a lot of different sort of concerns there, right? And so what we could do is very simply, like, we could try twice and then give up or whatever. Like, there's different things we can do. We'll be looking for, there's a really interesting way I solved this on the Witness that I hadn't actually seen anyone talk about before, that I've sort of considered doing in Handmade Hero, but I don't know if it's the most appropriate thing for it, so I don't know if that's a good solution or not. But we will look at various solutions later when we do our full collision detection. But so for now, we'll have to do something, that's somewhat janky, right? That's not the nicest thing in the world. And so basically what we would do there is say, okay, if we correct our velocity, let's try using that velocity on this frame, right? And again, that's not exactly correct either. Okay, so I'm going to go ahead and wrap this in a for-i loop. We are going to do the new player P, right? We've got the player P offset that comes in here, which we try adding. And then we go ahead and say, once we've actually computed that declare P,
I can finally see this code up here that I was looking for. I wanted to see if there were some details here that were different, but there is not. Not that I can see. Well, yeah, no. We up the player speed to 50 if we have the arrow key down, and we add to the player's acceleration some friction, right, based on the velocity of the previous player's game state. Those values all look the same, so.
Right, okay. And so what we need to do now is say, all right, now that we've actually computed a new declare P, we need to be able to try again this basic process, right? So I'm trying to think, this is a reflected vector that's happened after the acceleration was tried, and do we want to do, how do we want to do that exactly after we've clipped that velocity? I guess we just want to move him by that velocity that we actually have left. So I guess I don't want to solve this in this stream, because here's what I actually want to do, and so maybe we should save this for tomorrow, because we just don't have enough time left. What I actually want to do is I want to actually sort of show a slightly more correct collision response here, which is when we have this motion and we find that we intersect, I want to back up to the point where we hit and put the guy there, and then correct his velocity, and then step it forward, right? I want to do something like that. And so I would rather do that potentially. It's such a tough choice here, guys. Or maybe I'll do the thing I didn't notice. All right, so you know what? Let's table this till tomorrow, because we don't have any time left. Let's get ready for the Q&A, and let's just say this is a to be continued that we will talk about tomorrow. And I'm going to think about which way I want to solve it right now, because I think I might want to actually try the witness way, because it's actually kind of cool, and I think we can just do it here. And then whether or not we can actually do it a little later on, I'm not sure, because there's more to the witness way than the way that I would be able to do here. So let's just table this for now. It's 8:59, and we will pick it up again tomorrow. So we can start the Q.
So then he's going to jump in the Q&A, and I don't think there's really any more code changes that happen during this day, which is why I wanted to kind of split things up this way. But there really wasn't much. But we got introduced to the linear algebra package, and of course I've got an errant white space. Get out of my life. No. Not allowed. So I'll just go ahead and it's just in the game package. What is day 44? Reflecting vectors. Just keep that discrete. I like to be able to jump back and forth between the end of each day with each commit in my Git history in case something turns up messed up down the line, and I just want to understand something better and jump back to that moment in the code, or I can look up what the code looked like at that particular day and time. I've done that a few times, actually, just going back to my Zig code to figure out what the heck I did in Zig to do the same thing, to figure out how to do the same thing in Odin, but it inevitably looks a bit different just because, Zig does things a good deal differently from Odin. So with that out of the way, I think I can just jump on to day 44, and we'll kind of continue right along the coding portion in day 45, because, and did that show up right? Yeah. So in day 45, the first 20 or so minutes, Casey goes over the different approaches to handling collision, and he also explains what he was just talking about, which is the witness way, right, of handling collision detection. And maybe he'll articulate it here. I think I put it to just a few minutes before he starts coding, but he explains that the witness way doesn't involve, because in the witness it's like a puzzle game, right? And I've never played the witness, but I think I need to at some point. He explains that because the witness doesn't have a whole lot of different moving entities doing things, like enemies and NPCs and all this sort of thing, projectiles, this movement collision that he implemented works well because it doesn't have to account for those things. But if you do have those things, which I don't know for a certainty that any game that I would care to make myself would have a bunch of different entities moving around. Like if it was, well, even if it was like we were just talking about, a free climbing, sort of wall running type game, if you had platforms moving, if that was the only thing you had to deal with, then maybe that wouldn't be a big deal. But if you had a bunch of different stuff going on, a bunch of different platforms and like projectiles trying to shoot you, or knock you off the platforms, then, maybe that still wouldn't be right. But anyway, we'll go ahead and jump in here.
Another problem. And the reason that we would want to turn him into a point, the reason that we'd want to think about him as a point instead of as a sort of a circle, is it's much harder to collision detect with a circle. For example, if I have a wall, and I want to know if the guy hits the wall, if he's a point, right, then I'm just talking about checking a line segment against another line segment, right? So I'm basically checking for the intersection of two line segments, which doesn't sound like a very hard problem, right? But if he's a circle, now I have to check an extruded circle, right, versus a line segment, which is definitely a more, a more serious problem that you would have to solve, right? So in the first scheme, if for search and T, this is definitely a problem, right? Definitely a problem, because now you have to have a more serious collision routine there, and that's a bit rough. So similarly, in our scheme that I was proposing we do, which is search and P, for search and P, it also is a problem just in a different way. And the way that it is a problem is that if my guy has volume again, right, if he has an area, then that routine where I check for the closest point is a little harder as well, right? Now, it doesn't happen to actually be harder in just this one isolated case, meaning the thing that we're going to implement today, it's actually pretty easy. The reason it's pretty easy is because if the guy is just a circle or an ellipse or whatever, then all we really have to do is when we're considering the rectangle that he could be in for finding the closest point, instead of using the whole rectangle, we just look to see if the square on a side of the rectangle is filled, and if it is, we just treat the rectangle as if it was the ellipse's radius in that direction away from the filled area, right? Like that. And again, this is just another way that search and P is superior to the other method, is like, this is way easier than trying to do that continuous collision detection, yet it handles the continuous case just fine. You will never tunnel through anything as long as you do that flood fill pattern. So it is a little more complicated than I originally said, but only slightly when we do it this way. But you can see when we go forward why it will complicate matters to have him be a circle, because let's say that we had some arbitrary collision geometry, right, that we were colliding against, and now the guy is a circle. Well, doing the closest point, figuring out what the closest point in the walk space is to here, is definitely harder now that we have to consider like this sort of fact that his closest point region to search is like this thing that looks like that, and we have to determine that. Like you can see this is really ugly now, like how to do that. So if he was just a point, we would just search along the edge of the collision boundaries anytime we hit them. That's a lot easier than trying to figure out how far away we would have to be for our circle to fit. It's not even as simple as just thinking, oh, I'll take a point and move it out, because you never know, there could be a sharp bend where moving it out from there actually still makes you collide with some other piece here. So it's definitely something to think about. This is also where Minkowski, the Minkowski shape algebra stuff comes in, potentially, which we might use when we go to stuff that's more complicated like this. But for purposes of specking out our engine, this would be fine, because if we say that we want to go with search and P at least at the beginning, then that at least gives us a good way to define what our engine needs to do, which is the whole point of all of our explorations now, which is that all we need it to do is be able to give us back with a P and a P prime, give us back the closest P that we could have gotten to from there in the connected space. That's a very easily defined problem. It's very clean. The API is obvious. So all of that actually does exactly what we need it to do for now, which is tell us what the sort of API is to our engine, and that will allow us to know exactly what problems our engine does have to solve when we write it. Okay, so hopefully everyone's pretty clear on that. So how do we write that? Because really that's just a bunch of code, right? There's not much math involved there, really, in terms of what's going on.
Bugs hide from Casey because he's the apex programmer. I do think there's something to like the level of experience that you have corresponds to the kind of bug that you'll come across, almost, like, or at least to what you're... the way you start chasing down a bug varies depending on your level of experience. And some of this is just like you get more effective at finding trivial bugs. But the really sneaky ones, the sneaky ones for me these days, like I just spent a couple of days this week trying to track down, I was trying to update some state on this WebSocket as part of this multi-image upload feature I've been working on. And there's a lot of code that's being called in all of these different places, and like to actually get the instructions, the sequence of steps of different instructions that the WebSocket, goes through, all these different function calls where state is being modified on the WebSocket. I've been working on that project for so long that I take it for granted that one function call that I've made is making some call to some other code that I might have written years ago, and it's not even like loaded into my, the RAM inside of my head, and so I'm just not thinking about it. And then I realize, oh, well, that's my bug. The state is being changed in this place where I forgot that state even changes over there. And that's because I was too arrogant I was arrogant enough to think that there's no other code I could have written that was doing this sort of thing. I thought, no, clearly something I've written within the last, 10 days of working on this feature, or however long I've been working on it, is why this isn't working the way I think it's going to work. I don't know. It's just you'll be surprised by the manner in which you can still get your ass kicked by bugs that you thought like were really tricky. Like there was something, like I thought I had two different, and depending on how you want to look at the problem, actually no. So I came to such a bad conclusion here that I knew couldn't be right, and that's when I started to backtrack and investigate. Oh, there must be some other code I'm calling somewhere that's messing with the socket, the state of the socket, and I'm just not, intuiting where that's coming from. But the reason where I came to that realization was that I was starting to come to a completely bad conclusion, which was I clearly have two different sockets that I'm dealing with right now. But my brain couldn't, my brain had started to convince itself, oh, I just have two different states. No, that as soon as I started thinking like that, I was like, no, you have to go back to basics here and really peel back the layers of what it is you're doing. And that's what led me to realize, oh, yeah, the state's being changed over here. I had one piece of state on the socket that was fine and exactly what I needed it to be before it went through this other function call. But I never bothered to check before that function call to see what the state was. Because if I had done that, much sooner than I did, I would have seen, oh, the state is fine going into this function call. It's once the socket gets updated and spat back out that it's messed up. So it was I felt pretty foolish once I finally figured it out.
Going on. So all right, let's write it and let's see what's going on here. So right now, what we're doing is we have this is tile empty or whatever it is that oops, not get tile, is tile map point empty, right? This is how we're doing it. This is our routine. And so what I'd like to do now is sort of totally change the nature of what we're doing here. I'd like to basically say all this stuff that we were doing before, this stuff is over. It's done, right? It's not the case anymore. We're gonna get rid of all of this stuff that we used to be doing, like that. And honestly, this guy could have been outside here.
It breaks my heart a little bit when he does that because I can't do it that way. I can't just if zero out all of this code. I have to get, annoying with my conditionals. So once we declare player left up here, and then all the way down to here, I think. He's gonna exclude that, and I guess I'll just do this, as bad as that is, just so we can have it hanging around. And then over here, what does he do with this? I don't know what he's gonna do with this, but
Case anymore. We're gonna get rid of all of this stuff that we used to be doing, like that.
Oh, okay. So this is gonna come up here. Is that right? But this is where I close that block. This is gonna close this else, which I don't want.
And honestly, this guy could have been outside here before anyway, because this is always true. Our on same tile. All we really need to do is say that this is an old player P, right, and a new player P kind of a thing. So what I'm going to do here before I if0 it out, actually, let me just actually change it to do that so that our post execute stuff is still going to work properly. So basically, I want to know if he's on the same tile. So I'm going to set old player P when we first come in here, right? I'm going to set old player P to be equal to the position that he started at. So when we come right in here, just to begin with, I'm going to set the old player P, right? Old player P equal to game, that game state. Remember, we've got his player P here.
I thought so hard about that, and then he just undid it. So I'll just back that up. And then up here, when we open this up, we get our old player position out.
I'm going to set it to equal to that player P, right? And actually, you know what? I'm going to do that even outside here, really, because this is the part that updates where the player is, and then the part that responds to that, let's just do that entirely outside, right? Because all of this stuff has nothing to do with that, right? That's all stuff that can happen out here, right? So what we want to do is say if the old player P and his new location, right? The old player, right, entirely outside.
Where did he assign that? Okay, up at the top of the loop. So, okay. This is like the most painful part of doing this on stream, is just like the moving of code around. I have to be paying very close attention to make sure that I don't do something very bad that leaves me in a very confused and broken state. So then he moves that code out, starting with that R on same tile check. And this is just going to be pulled out of there and moved here. And then we bring all of this out of that whole loop. And he's going to shove it just above the call to draw the backdrop. And new player P is gone, because he's just going to work off of the current one. Okay. So this becomes that, and this becomes that. And then all of these new player P references are going to be changed into the current game state player P. In fact, most of them already are, because at this point we've assigned the new player position. I think I get it.
That use of new player P at all, right? I want to directly operate on the game state version of the player, right? And so let's compile that and just make sure that we can do that. So this is tile map position, and let's take a look here. What is this saying? To diff multiple. Oh, do I have another function called diff? I do. Oh, and that happens to be the same. That happens to be the same diff. So really, all I need to do here is just update that diff. That's pretty funny. Yeah.
Okay, so what he's saying is we get. I don't even remember doing that. We did do that multiple times. Yeah. I didn't pick up on that. Okay, so change all of these. And then instead of declaring a new diff, we just update the old one. There is something about talking out loud as you code, and I've noticed this more and more. I have a coworker that I work with pretty closely, and have done so for the better part of almost a decade. I've known him for about 8 years or so, and I noticed that I figure out things more quickly when I'm just speaking out loud to him and articulating things versus just like sitting there in my own little bubble and thinking it through on my own. And I don't think it's necessarily, not that his feedback, our feedback going back and forth makes us both more effective at times. Now that's not, you don't always need to do that, but I do find that like when you're trying to lay out a problem and make sense of the minutia of it, it really helps to talk to somebody, or even just talk out loud to yourself. Like I'm noticing it's helping me just make sure I don't make any mistakes here on stream.
Because that's funny. Well, what are you gonna do? All right. So let me just verify that I've still got this guy working properly. So off we go.
It doesn't ever not feel a bit weird, but still, it's like a rubber duck, but it's a real duck. Yeah, that's what I keep like thinking to myself. And also Casey, even though it's one-sided, like him obviously teaching and doing the lecturing and stuff, it like when he says it to me, I'm like saying it back at him, even though he's not really here, right? But if I need to, I can replay it, and then if what I originally said was not correct with what he said, then I can say it again, and self-correct. And there's just something about how powerful that means, the language center in your brain is, right? Like actually using speech versus just using thought. And I think there's something relevant here to like the whole, remote versus in-office thing. I think you can get a lot of the same experience if you have a good enough relationship with people, like I do with this coworker I'm referring to. But if you didn't have that, if you didn't have anybody that you trusted to be like have a open conversation with as much online versus like being in an in-office setting, I can see where you would actually be less effective, because there's something about being around other people and connecting with other people's thoughts and ideas and using them as a sounding board for your own thoughts and ideas and vice versa. That is what, makes the magic happen, so to speak.
That looks okay. You can still go up and down the stairs. Still runs into walls, as he should. So we're all good there. All right. Oops. There we go. And so I don't know, like this is starting to get to the point where we might. This is starting to get to the point where we could think about starting to pull it out too. You can sort of see it breaking out into some obvious pieces, like those parts that I just moved out there. You can kind of see that there's two separate, logical things that's happening, right? There's this update that happens after the player's done that kind of handles a bunch of stuff. And so this may be a good thing for us to move out now, because that's going to be kind of this is basically a update function that updates the sort of the state of the game based on where the player moved and the camera. We might want to consider moving that out to a new function. I'm not sure if we do yet. Hard to say exactly what that's going to be, but like I'm going to put a note in here: update camera and player low z based on last movement. Right, and then here we'll get render. So I'm just going to start to divide these up, and we'll consider at some point whether we want to break that out, because we're getting closer to the point where it looks like we can start to see, real chunks that happen. And by the way, this is a good point to mention this. Somebody was saying on the forum.
Before he goes any further, I didn't catch that other note. And then down on the draw call, yeah. Render. I like it when he adds these notes in here, because it helped me a lot trying to make sense of like what is the flow, getting an intuition for like what is the flow of how a game loop even works, right? And very naively I could say, take some game input from the player, hand it to some logic that processes the entities, and then go ahead and draw the new state of all those entities, right? And that's a very short explanation of what's going on, but unpacking all of that is it's one thing to be able to see that or say that out loud and be like, I get it. That's like if you play a game, if you've played a lot of games, you can make sense of that. But getting it all out on code and creating the blueprint, like Casey would call it, to hand it off to the compiler, there's just so much going on.
Whether we want to break that out, because we're getting closer to the point where it looks like we can start to see real chunks that happen. And by the way, this is a good point to mention this. Somebody was saying on the forums a while back that they felt like the code was too messy. And again, I really want to stress the fact that I don't really want to try to tell people that the way that they code is wrong, because I feel like that just leads to a lot of pedantic arguments that aren't particularly constructive. But what I can say is, in my mind, nobody should be thinking that this code is messy. This code is exactly what it should be. It's code that we are writing to figure out how we want to structure our program. And if you're spending time right now thinking about how to make this code not messy, whatever that means to you, then essentially what you're doing is you're wasting time, right? You're spending time that should have been spent thinking about the problem, thinking about the code. And the end state, the end goal of your program is not to have clean code. It's to have good working code. Cleanliness has nothing to do with those things. If you have the ugliest code in the world that someone would look at and call very messy, but it has no bugs and runs great, then it didn't matter, right? And so to the point that we care about how clean code is, we only care about that as insofar as it has an effect on our end product. And what we know right now is what we're trying to do is just define the structure of the code. So none of this code will ship in the game, or if it does, it's because it got pulled out and changed around a little and put in its proper place. And so we know that it will clean up over time as we know what it should be. But prematurely cleaning it, it's actually worse than just wasting time. It may lead us down wrong paths and end up making us have to do gyrations to make stuff work together because we've segregated it in a bad way too early on. And so I really want to stress that fact that if the way you look at code is that you think of it as messy or clean, that is a very bad habit in my opinion. And so all I can really do is say as strenuously as possible, stop thinking that way. Instead, think about the problem you're trying to solve. When you are done and to your satisfaction solving that problem in however messy a way as you can, then that is the time to start thinking about cleanliness of code. And what we mean when we say cleanliness of code there is, can I find the bugs in it easily? Is it easy to read and understand? Is it easy for me to reuse in the places that I need to reuse it? Those sorts of things. And never some set of prescribed things that somebody said was clean code, because there is no such set. There is no set of rules that tells you whether a particular set of code is clean based on what the code looks like. It's only based on what the usage looks like and what the debugging process looks like that actually tells you whether a piece of code is clean or not. And I really can't stress that enough. It's a big difference between good programmers and bad programmers, is whether they understand this, right? And that's, like I said, it's my opinion. Nobody has perfect metrics for code, so we don't know who's right about those things, but all I can tell you is in 30 years, I've never seen something truer than what I just said. All right, so.
I feel like I pretty much agree, and I would have had a hard time even understanding what he's getting across until I'd had many experiences like that where I was trying to make the code as neat as possible before moving on to some other thing. Part of the problem, though, is that you never quite know if the problem is fully solved. So if you never know when the problem is fully solved, at which point do you actually start coming back around and cleaning it up? Right? I still struggle with this to this day because I've been working on one project in particular now for a long time that it feels like it's just never going to be done. But with that being said, I do the neatest thing I can think of at the time to solve exactly the thing, and then I move on. And that's about the end of it. I don't try to sit there and come up with the perfect abstraction, because generally there is no, all the abstractions that I need, for solving any sort of web programming related task, whether it's on the front end or at the database layer, or on the back end with the way that data is massaged going in and out of the database. There's no abstraction that I need that the framework I'm using hasn't already solved for me. And so I don't really mess with metaprogramming. I don't define my own macros. Generally, if there's something that I need, somebody else has already done it. So in many ways, it feels like a lot of those problems are largely solved and I've been beaten to the punch. But people are always coming up with new, slightly better abstractions, either in different frameworks or using different tools. And, in different languages. Like the one that I've seen so much of over the past couple of years is Go. Well, not necessarily Go specifically, but HTMX. Using whatever language you want with HTMX as your front end solution of choice versus using React, right? But I'm in a position where I can't choose to do anything differently. I'm locked in to all of the decisions I've made until, for some reason, I decide that I want to start from scratch, which I can't do. I'm too deep to make any other choice at this point. But I'm mostly happy with the choices I've made. I'm happy with most of the choices I've made. But even if I wasn't, there's nothing else I could do differently at this point.
Moving on from there, from that little public service announcement. What I want to talk about now, right, is sort of radically revamping what we're doing here to something much simpler and much better, right? So we still have our physics stuff up here. So this is computing the player velocity, right? And what we want to do now is right here, we want to sort of if-zero this out and say the old way that we were doing stuff, that's not going to happen anymore. That's done, right? That's over. And we're going to do something else that's going to be better. And I'm leaving that in for now just because we might want to switch to it to see what's going on, right? So that's all good.
Make sure I properly carve this out now. So new player P, once again, we're going to move all of that out. And he's including this else. So if we move that down a branch and then we say we're going to handle things this way, that should be close enough to what he's doing. Because he just has this else where he's going to start throwing in the new code, and then he has the end if there. And I think that's right. It looks like he started a note here, and then he just didn't fill it out. Hopefully he fills that out, because I didn't see him add anything there. He just had his little speech where he said, quit, you know, trying to make the code neat before you've solved the problem. And then, but then he didn't actually write anything in. What's that about, man?
We were doing stuff, that's not going to happen anymore. That's done, right? That's over. And we're going to do something else that's going to be better. And I'm leaving that in for now just because we might want to switch to it to see what's going on, right? So that's all good. All right. And then what I want to do is say, okay, let's go ahead and say, let's do that thing that I was talking about before. And for now, we'll just do it without any concern for anything. We'll do it in the worst possible way, and then we'll refine it a little bit. So I'm just going to go ahead and do a for I loop around, basically in that sort of region where the player is and where his destination point is. So we're going to basically say, I'm still gonna keep this part for now of the physics, right? So we produce that new.
Go back up to where this is, and then yeah, I mean those are the equations of motion that we worked so hard on. Got to keep those.
Player P, I'm going to keep that, and I guess we want to do this. So, but the rest of this stuff where we do all the collision texturing and the testing.
Hold on. Hold on.
So.
Okay, so this right here. Yeah, that's right. That's where he originally carved that off, I think.
But the rest of this stuff where we do all the collision texturing and the testing, I'm not going to use, right? So what I want to do now is I want to basically loop over the search region in tile space, right? So I want to be able to go over each individual tile there in X and Y. So I'm going to go ahead and do that, and we'll take a look at handmade tile.h here. I'm going to go ahead and do that and say that, you know.
I love this username. Gustavo Fring has joined the chat. Send me some Los Pollos, will you? Thanks for dropping by. You get that son of a bitch, Walt.
Min tile X, max tile X, like so. Abs tile X, like that. And I think, so there is one kind of nasty thing about this. This is kind of, yeah. This is one of those things that's like, it's unclear whether we should change it going forwards. And I thought about it many times on the stream when we've been doing stuff, basically the unsigned versus signed integer thing. So there's a nasty thing here that happens where we're right on the edge of a tile, where let's say that we were, here's the, let me just, I'll get this out.
I'll just write this in. He's going to just start describing, you know, some pain points with switching between signed and unsigned ints, which I encountered a lot of writing this all out in Zig. Okay, so this is going to be over the abs tile Y in min. Do we have a min tile? I guess he hasn't defined those yet. Min tile Y up to max tile Y. Place Y with X. And I didn't do this right. Does he go up to and including? It looks like he does. What are you expecting? Expected an operand. Oh, it's because you just say equals to, right? So now our problem is just that we don't have those declared yet, but that's okay. Yeah, I ran into so much trouble with casting back and forth between uints and ints and Zig. That is part of the reason that I was incensed to look at Odin more closely after writing Zig for about 9 months. I guess I'm just more of a masochist in that way, because I've read a bunch of other people who are trying out Odin saying similar things after writing Zig for a week or whatever. But I think I needed to experience that pain fully and more measurably to really appreciate that, because a lot of these people probably came into trying Zig because maybe they are really familiar with C or C++ or whatever from writing Unreal or whatever. Maybe they work on C++ code for work, or maybe C#, right, if they're doing Unity stuff. But I don't know. I didn't have any experience, so I just dived in with Zig, and I thought maybe this is as good as it gets, because everybody's singing Zig's praises, and I don't even say any of this to disparage Zig, because clearly a lot of people still like it, but Odin is shaping up quite nicely in this respect.
Where, let's say that we were, let me just, I'll get this out there since I've thought about it multiple times, but I've never mentioned it on the stream. I'll just say it here. So let's say we happen to be at tile 0, 0, right? So this next tile here is, tile 4 billion, because we wrapped around, right? If I want to do a for-I loop over these tiles, there is really, it's hard to write that loop cleanly, if that makes sense. Because you can't do a less than. So you have to kind of do an equals to, which maybe is okay. Sorry, not equals to. Because if you think about it, when you go back here and I start looping over this guy, when I loop over him, we're going to see that he's already greater than the stopping tile, which is the one that we were looking at over here, because of that wraparound of the unsigned integer. So I don't know, I'm just going to go ahead and keep on with the current way that we're doing things and see. I've thought about it a couple times, but basically we have to do this like that kind of. We always have to do a not equal to 1 past the max tile, because that's the only thing that will actually work when we do this loop. We can't ever really check for less thans, even though that's the more easier and natural way to think about doing the loop usually for me. We have to do these not equal tos, because we might be right on that boundary where we're wrapping around, if that makes sense. If we don't have to do that. We don't ever have to let the world wrap around if we don't want to, but I'm saying if we wanted to actually make the code correct so that you could have a full giant 4 billion loop for some reason, 4 billion tile loop, if you really just wanted to, it's something to think about, right?
Well, I don't think I can do that the way he just did it. Well, maybe I could. Yeah, I could if I did like a C-style for loop, but whoops. I don't think this works, right? Like I can't say not equal to using this for syntax. It'd be nice if I could. I'm guessing I can't just, wrap it in a paren like this. Yeah, you can use less than or you can use equal to. I guess what I'll do is leave this here and maybe think about this more later. But for now, we can just do the C-style thing, which would be like set this equal to the min tile y, if I can type correctly. And then say if abs tile y does not equal, oh god, I'm gonna have to do this way because the code is too wide. And then abs tile y plus equals 1. And that goes over here now. It's unfortunate, but it is what it is. So we still don't have those declared, but that's fine. And I'll say, and I don't even know if this really matters, because I think Casey walks back the toroidal thing, and he just makes the world bounded. But for my own edification, I'd like to know, can we do this, do these fours in the syntax, in the below syntax? Sure.
So anyway, if we're looping over here, then what I need to do inside each of these ones is just figure out whether what the closest tile would be. So the first thing I need to do is I need to look up that tile, right? So I want to say what's the tile value in that area, right? And so I believe we have a way of doing that just flat out, which I do. And so I can pass these guys in there and get what the tile value is. So here's the tile value. I can look at that tile.
So he's doing that differently. He's passing in the app style X, Y, and Z. So it has to be this get tile chunk, but kind of like what I was talking about earlier. I want to say, actually, is that right? Tile chunk X. I don't know if that's right. You know what? I think I changed this actually, so that, yeah, no, this is, I think it's just get tile value. Well, I want to try out the procedure group thing, but also I changed this to just take a tile map position, because otherwise it just wrapped like the same thing. It wrapped a call to like a proc that does basically this. So we would say tile map position, well, we'd say pose equals this, and ab style X, ab style Y, ab style Z. Those are all undeclared, too few values, right? Do we care about the offset being set? I could just say 0. Yeah, I think that's fine with me. And then we would pass in the tile map, except I don't have one. And then pose, right?
Value and say if tile value is empty, right? I believe it's 1 is our blocking thing. Let me make sure. Yeah, like that. And for now, I guess maybe since I've got enough of it, I'll also do a thing that is tile value empty. So, right, something like this.
Got to go into our tile here, tile file. Say is tile value empty.
Does that make sense? Just so I can reuse.
That does make sense. So just throw that in there. Result. Return result. Then in here, we say empty is tile value empty. Tile chunk value. And it helps if you give the procedure a parameter, doesn't it? Is it an int? What comes out of here? U32? Yeah.
That check. Is tile value empty? Tile value, so on.
Yeah, I guess the more succinct name is fine. Oh no. Oh jeez. How hard is it? Just take your time. There you go. Yay. Took way too long to do that.
That way I don't have to keep thinking about it. And again, we're going to replace this stuff anyway because we're going to have to decide much later on, probably after we do the render and we start thinking about what's actually in a given game tile, we'll have a representation for the game tile. For right now, we just have some numbers we throw in there for no apparent reason, just so we can have some variety and think about what's actually in the tile, right? But that way we can say empty equals is tile value empty, and then we pass that, and this tells us whether it's empty. So then I'll just do is tile value empty, like so on, and if it is, then we can actually check to see if we can stand anywhere in the tile or see where the closest point in the tile is, and if not, we won't, right? Okay. So the next thing we have to do is check the tiles all around us, right? We need to figure out what our rectangular space looks like for this for the purposes of checking. Now, one thing I got to think about here, because I'm not even sure myself, I got to think about this. Never done this before on a tile map. Tile maps are new to me, by the way. I just decided I kind of wanted to do them for this game because I'd never done a tile map game. So, you know, stuff I got to think about too. So in the tile map, let's say that we've got a guy here, right? What does that imply for our circular, if we had a circular style hero, right? Well, it means that from at least right here, we've got the radius worth where he could stand. And then I guess what it does is it makes it look like this, right? Meaning he can stand anywhere in something that looks like this, right? And that is rounded right there in some sense, right? He could get closer to it. So it's basically like a arc that's his radius wide coming from the corner that cuts out that segment of the thing, right? Because if you imagine the dude standing and he has to stand, I'm talking about this, right? You imagine him coming up. He's a circle or something. He's coming up to this point, and if he's going to run into that point, then basically what's going to happen to him is this radius of the circle, this r. If he came into it this way along this edge, he would stop r away from it. He'd hit it r away from it. And if he came into it this edge, he would stop r away from it as well. And then he could walk all around it, always maintaining r's distance. So essentially, you've got that kind of notch in there, right? So basically, the shape of the area in which you can stand is if there's a solid wall here, then it's just r. It's that whatever that radius is moved in. But if there's if there's diagonals, then there's notches like that, right? Does that make sense? Hopefully that makes some sense. So basically, there's like 4 walls that could be there for him, and 4 notches that could be there for him. And we don't really have to handle the notches right now if we don't want to. We could just not handle those cases. Like I said, we just have to spec out that we want the engine to handle them. So maybe we'll skip them for now, so we don't have to spend a lot of time doing that when we're just trying to do spec code. But we gotta know. We gotta say that that's what we want to have happen, right? All right, so is tile value map empty there? If it is, then we have to go and say, all right, let's define the actual valid region where the player could actually be inside this tile. And so essentially that's going to be a min max x and a min max y, right? And so we'll make those v2s for now. So let's say we got our min corner and our max corner, and we'll initialize where those are, like where the actual min and max corner are. We know what those are. Those are the tile side in meters. In meters, right? Divided by 2, right? So basically, I know that the min corner is there, because remember, everything's tile relative. So from the center of the tile, it's half that tile side meters to get out to the min corner, and then the max corner goes like this, right? So
I'm guessing that is on the game state, and that's why I can't see it. Something like that. Right? Is that right? What is this saying? There is no tile side in meters. Huh. Where is tile side in meters? Oh, it's on the tile map. So I can do this again to splat it into both values, I think. Of course, it's still complaining about something. I think, oh, because we're not using it. That's fine. And this should be negative.
I can also say if I wanted to, and you know what? Here's an interesting thing too. Again, for vector, I could do this, which is kind of handy, right? And that, like so, I believe. And I got to do these guys: min tile x, min tile y. So, got to put something actually in there. 1 past max tile, 1 past max tile. There we go.
Just gonna set them all to 0, I guess. So max tile. Well. Oh, I forgot to change these. That's right. 1 past. And then 1 past. So min tile x, min tile y. 1 past max tile x, 1 past max tile y, and they're all U32s. Still don't know where we're gonna get the abs tile z from.
Okay, and the abs tile z for right now, we don't actually check. He's not really allowed to walk upwards at the moment. That's something we might want to do eventually. I'm not sure how we're going to handle upwards movement in terms of how the player actually does it. I assume that they can't really move upwards. They just walk up, like specific tiles or like ladders that go up or something. That's typically how these games work. So we'll have to see, what we want to do when we actually get to the point where we've got, where we're really thinking about how we want it to look when the player goes up, right? But the abs tile z is just wherever the player was, and the tile side meters is, I believe, a property of the tile map, right? Like so.
Well, that answers that, doesn't it? Game state, player P, abs tile z.
Okay. So that's about it in terms of initializing that corner. So now we know what we're gonna do here, and we could do just right now that.
I guess I should make sure that I can build here. Oh, man. I run into this so often now that I've been considering just turning the vet flag off until I decide otherwise, because it just leads to me writing more stuff than I need to. Okay, we're stuck because we can't go anywhere because we're still working on this code, but I can build. That's all I wanted.
That search, we could do the search right now. So the first thing we could do is say, well, and let's walk through this search. We don't have a whole lot of time left, so I don't think we're going to finish this today. We've only got 10 minutes left. So we'll do maybe part of it today, and we'll do part of it, start picking up again on Monday. So if we think about how we want to do this search, right? We've come up with a tile, right? We've looked at, and you know, this is the part we're going to do next. We've looked at, let's say, what's blocking him, and we've come up with a rectangle. That's where he could stand inside this tile. And now we have a point somewhere, and we want to know what the closest point in our rectangle is to that point. So what are all the cases, right? Well, the cases are either the points inside our rectangle, right? So the point's like somewhere in here, right? If the point's inside, then it's just the point, right? So one case is, you know, it's just the point if it's inside. So if it's inside, it's just the point. If it's not inside, that means that nowhere inside this rectangle could possibly be the closest point. The only places that could be the closest point are on the edges, right? Would have to be on the edges. So if it's on the edges, then what we need to do is we need to check each edge, right? And which edge do we need to check, right? Well, we need to check whichever edge is implied by the delta between the tile center and this guy, right? So when we check and we look where this guy is, all we really need to do is go, well, is it less than or greater than in x for us, right? If it's less than x for us, in fact, you know what? This is going to be such a cakewalk. All we really need to do is say, okay, if it's less than that, this is basically just a trivial clipping problem, right? It's really nothing to it. We just start with this and say, okay, if he's less than our minimum bound, then just put him at the minimum bound, right? And if he's less than our if he's less than our maximum bound, yeah, this is going to be really, really simple. This is going to be really, really simple. So the closest point, right, would be here in this case, I believe, right? Is that correct? So if we're looking at what the closest point is, no, that's not true. The closest point would be here. Yeah. Okay, even better, even better. All right, sorry, I got distracted there for a second thinking the problem through. All right, so the closest point to a rectangle is actually just going to always be a perpendicular to the edge, right? Because I was thinking closest point to the center there, and I was like, oh, we got to find the intersection. Not true, because we're not looking for the closest point to the center. We're looking for the closest point to the rectangle. So basically, this coordinate, whatever this coordinate is relative to the center, is the closest point once you actually clip its coordinates to the coordinates we have. So if it's less than our min x, we just clip it to our min x, and bam, it's the closest point, right? If it's less than, you know, if it's greater than the x or the greater than the y, we just clip it to. And as long as we just sort of clip it to whatever it is, then we've got that closest point. I think that's it. And that'll handle the corner cases properly too, because it'll clip it here. Like if it was out here, it'd first clip it to here and then clip it to here, and that's exactly what we would want. So basically all we have to do is just go through each axis, x and then y, clipping it to the bounds in that, and we've got the closest point. Done, right? So to me that sounds like something that I just want to call here. I want to say closest right point in rectangle. It seems like something we might want to do. Just in general, it's a nice, easy thing for me to say. So I'm going to say that our test b is whatever the closest point in the rectangle is. I'm going to pass that rectangle, min corner, max corner, right? So the closest point in the rectangle to that new player p, so relative new player p. And so to produce the relative new player p, I just need to know the difference between that new player p, right? This guy right here. Where's that subtraction? I've got that diff function. That's
Wait, what? He's talking about a relative new player p now? Okay. Sure. We're going so wide with these branches that we're going to be panning back and forth in the buffer soon, which is not awesome, but we'll do what we have to do.
Where's that subtraction? I've got that diff function. That's what I want. So what I want to do here is say, all right, I've got that diff function. I want to subtract these two guys. I want to subtract the tile point. So this is going to be my my test tile, and this is going to be my new player p, like so on.
Test tile came from nowhere, but I'm sure we're about to grab it somehow. Cannot assign value. We can if we turn it into a pointer. And so this proc does not exist, and this does not exist. We have a few things here that don't exist, but we'll figure it out. Maybe if I do this I don't like my code being so, yeah, I don't know what to do about that. This is not really any better. I need to figure out how to pan over is what I need to do. Because I just don't want my head covering up a whole bunch of code. Something to think about.
That. And the test tile P I need to build out of the abs tile X, abs tile Y, and we don't actually even have a function for that yet, do we? So our tile map position, I'd like to be able to make one of these easily without having to specify the offset, which I could do just by doing it directly, but I'd like to be able to search for those. So I think what I'm going to do is introduce something here where I can sort of say, you know, centered tile point or something like that, and I just pass abs tile X, abs tile Y, and abs tile Z, like so on, and can basically produce the result that way. So result is just a straight copy of those things. And it is assumed that it just like the other fields are 0. So we'll return that like that.
It's kind of what I'm doing here, so I don't really care to recreate that proc, but I guess what I could do, so I don't have to add this 0, is like we could just provide the name, which is what OLS was telling me to do, right? In fact, we could even abridge these names and just say these are X, Y, Z, just so that, you know, so that this is less chunky, because this is a pretty chunky for loop here. We'll just leave it like this for now.
And that way I can quickly generate this guy, you know, with actually no. And again, we're not thinking about speed here at all. That's important to remember. We're just thinking about writing code that works at this point, and all the stuff that we worry about speed, that's all going to come later on down the road. So I try to be aware of algorithmic problems if there's a speed problem in that sense, but you know, I try not to think about that in terms of when we're just working on the code directly. All right, so let's go ahead and compile that, and now we have to, let's see, what is the problem here? Cannot convert argument 2. Oh, right, these are addresses. Am I correct about that? Yeah. And so this is rel new player P. So now we got the relative one. So all we now have to do is do that. So assuming that we...
I see. So he's turning this diff here. I got it. Okay. New player P. That's relative to... We gotta push this out now. So the test tile that... What's going on here? Just gotta orient myself so I know exactly what it is I'm working on. So we're checking all of the tiles. We're gonna have to figure these values out. We're gonna have to assign those properly to be something other than 0. So that's part of why I'm a little bit lost right now, but that's okay. But this is all gonna be relative to the position we're trying to move to, right? And we say if that position is empty, yeah, I don't know, but test tile P is still, he still doesn't come up with that. I guess I should wait for him to finish. I'll let him finish.
Have that. We have our best point. Our best point is going to be wherever we start. So the way that I'm going to treat this is going to say wherever the player is right now, that's going to be the best point, right? So the tile map position that we expect, our best player P, right, is going to be wherever he is right now. That's just what we're going to do. And then so when we're actually doing this resolve here, I'm going to say when we get back the closest point in the rectangle for that test P, I'm going to then see whether that's better. The distance is better, so I'll also say best distance will be whatever the best distance P is, the distance between the new player P and the old player P, which is again that diff. Do we have? I feel like we have this. So we know how much we added, right? So I'm going to actually save that. So this is the player delta, right? However much we added to the guy is this, right?
Okay, so we're breaking some of this stuff up. Player delta is going to be involved in here, but if we go back to here, Right, so this gets pulled into that. Whoa. Right? Player delta. Calculated out. Plus that previous offset, because this is still working off the previous player state's tile offset.
This is what we're moving him by. There we go. And so that's player delta plus, so there we go, like that. I could actually just say that as well.
That does make more sense. Okay. So back down here.
So that's the player delta, right? And so if I want to, I can say however long that player delta is the best distance if we just stood still. So we definitely don't want to move the guy if moving him would cause him to move further away. So when we start out the loop, we're going to say that the best distance and the best location is just right where we are. And then each time we check a tile, we'll see whether where we would move in that tile would be better than if we just stayed still. And if it does, we'll update that to be the new best distance and the new best P. And we'll go from there, right? So we've got the best distance here. So we've got that best distance is going to be the length. And in fact, I'll actually do this squared here. Let's talk about this for a minute. We're almost out of time. Oops. I don't know if you remember, we actually implemented this, but we actually did the math for this the other day. I said if you wanted to find the length of the vector, you could just do the square root of the vector with its own inner product, right? But we never actually typed that in. So there's actually, if I just want to get the length squared of a particular vector, maybe I'll call that length SQ. That seems a little bit better. There we go.
Well, I get to see if linalg, the linalg package, has this. So if we are going to square that delta, well, couldn't I just POW? But that's the... I think this is it right here. Vector length 2. Because this gives us the length. And then vector length 2. Like that. I could just go for it and see what happens. Is that right? The inner product of the vector with itself? I think that's actually what he's about to write in.
If you just want to get the length squared, we actually already did the math for that on the previous stream. It's just that, right?
Awesome.
And that's, we wouldn't really even have to introduce a function for that. It's just a little easier to read. It's like easier for the person to read. Now, why am I leaving it squared instead of taking the square root to find its length? Well, square roots is extra work we don't actually have to do because we never actually care what the distance is. We just care if the distance is less. And we know that the square of a number that's less than another number is also less than the square of that other number, right? We know that if x is less than y, then x squared is also less than y squared as long as the numbers are both the same sign, right? As long as they're both positive, for example, we know that that's true. If they're negative, they might flip. In this case, it might be different, right? But this is the case for positive, and we know that distances are always positive. Like the length that you go, the length is always going to be positive. There's no way for it to be negative, so we're totally fine, right? So in this case, that's totally sufficient, and all we would do here is actually test to see whether it's better. And of course, I'm out of time, so we'll do that tomorrow. Sorry, we'll do that on Monday and finish that up. So we'll just leave that as a dot, dot, dot. In order to not leave our code in uncompiling.
How did I wind up over here?
Tomorrow.
So he ellipses. How do you say ellipses? He ellipses. He uses ellipses. I don't even know what I'm trying to say. He leaves this as to be continued, essentially. So if true, whatever, we'll just... If true, do panic poo. So we know for sure that is, you know, unfinished code. We won't get this looking the way it needs to look today, but next week, right? I still don't see where this test tile P came from. Oh no, wait, it's up there. It's It's this right here. Whoa, whoa, whoa. Oh, okay. Yeah, so I should just change this to be test tile P. And then I think we're good. I'm guessing this needs to be the address. And then we need to define this right here. I don't know where he intends to define that, but I guess I could always just do this. Although, of course, it's going to bark at me about not using things that I've declared. Ugh. Here, let's just do this. Well, that's not going to work either. I'm just going to stub this, I guess. Closest point in rect. We have to write it eventually anyways. Why not do it now? I'm kind of rushing because I have to pee really bad, but I don't want to. I just want to wrap the stream here in a minute and then go pee. I don't want to have to walk away and pee with like 2 minutes left in the stream. So this is going to take, what are those vectors? 2 vectors and then a tile map position. So we will say min, max, vector 2s, and then P is going to be a tile map position. And there we go. Does not return a value. It returns, we're going to want it to return a vector 2. And I guess I can just return an empty vector 2. Now what? Best player P point. That is not right. He just doesn't use it at all, does he? Not yet, anyway. I just want to set it up so that I can jump right in on Monday and we can wrap this up. Declared but not used. Best distance squared. Test P. Declared but not used. I thought I did see him use that. No, not yet. And then cannot assign rel new player P. Oh, rel new player P is not a tile map position. Is it? Where did he declare that? Oh, it's a tile map difference. Oh, okay. Okay. So, I don't have that because I'm making it a vector 3. Whoops. That's, oh, no. We still return a vector 2, but this is going to be a vector 3. So now it's just going to complain about these unused variables. I will get it to shut the hell up about that. Best player point, best distance squared. I think there was one more unused thing that it was complaining about. Test P. Yeah. Yeah. Okay. And then rather than, like you said, leaving it in a broken state, because we couldn't get to it today, we just swap this conditional, and we're at least running. Still skating, happily, merrily, off into an endless sea of rooms that all look the same, like some kind of psychological thriller gone wrong. All right, let's see if he does anything else here.
Sorry, we'll do that on Monday and finish that up. So we'll just leave that as a dot, dot, dot. In order to not leave our code in an uncompiling state, let's go ahead and flip this back and make sure that we're still working. Oh, no! Oh, I broke something. Yeah, make sure we're still working, and I did not make sure that we were still working. So it's good that I checked that. Let's just quickly see what I actually broke there. Oh, whoops, that's what I broke. There we go. Sorry about that. Slight error there. Slight error. There we go. Okay. Everyone's happy. There we go. It's all moving around. All right. So let's call it for now, and we'll go to the Q&A, and then we should have really no problem on Monday finishing that up since we've already explained everything that we're going to do. We'll just do that. We'll implement this function, and then we'll implement this check to accept it. Well, it'll basically be something that looks like this sort of thing. So this would be a new player P here, and the best distance squared will be the test. So this will be a test distance squared here that we'll do, and we'll basically say if the best distance squared is greater than whatever that test distance is, we'll accept the new one. So we basically just keep.
Okay. Let me pencil that in real quick, just so I'm not lost when I start off on Monday. Test distance squared is going to be what exactly? Did he say what it was going to be? Well, if it's going to be the same as best distance squared, and this is probably going to return an F32. I haven't seen this where before. Or maybe I have. Where is quaternion? Quaternion is mentioned. I'm excited to learn what the hell those things are. All I think I really know about them at this point is that they're relevant for 3D in particular, like rotations and stuff. Okay, so if test distance squared, I'll just assign it to best distance squared for now, and then we'll leave that, and we'll say if best distance squared greater than test distance squared, and then we're going to assign the new best player position to be whatever, and same thing for, well, this is just going to be the new test distance squared will be the new best distance squared, I assume. And this looks good.
Keep checking and keep picking a new best every time we see one.
Yeah.
All right, let's go to the Q&A.
So if anything interesting comes up in this Q&A, I'll be sure to talk about it next week. But pretty sweet. Wrapped up 2 days worth of coding, days 44 and 45 in a single stream. And then next week, looks like we're gonna add a second dude. We'll add very basic like couch co-op, right? So that I can jump in with one guy and then beam in with another guy on the controller, that sort of thing. So that'll be fun. I'm gonna go relieve myself and have a good weekend. I hope everybody who tuned in this stream also has a great weekend. Boston, Mass, thank you for that follow. Hope to see you again. And yeah, that'll do it. Excited to keep moving forward. We're 20 streams in, I think. Or no, maybe because I think I did one weekend stream. 21 streams in then, or maybe 22 if I did 2 weekend streams. So in 4 weeks, we've gotten 4 weeks of coding done, which is kind of the cadence I wanted to get on, where we're doing 1 day at a time until, we just kind of discontinue and go off on our own path, experimenting with different game ideas and adding different aspects to game prototypes that I can work on here on stream, and just kind of have a playground to experiment with different ideas. So looking forward to whenever we get to that point, but until then, we'll just keep going 1 day at a time. Till next time.